Hello everyone, I'm Karthik from ITS section. And today my topic is about quality guidelines for research certificates in model driven engineer. So let us know what are these quality guidelines for research artifacts in a model driven engineer. Uh, this topic is in software project management. So let us know this quality guidelines for research artifacts in model-driven engineer briefly in our further slides. Let us dive into our topic. Coming to the abstract, sharing research artifacts is known to help people to build upon existing knowledge, adopt a novel contributions in practice, and increase the chances of a paper receiving attention in a model-driven engineer. Openly proven as research artifacts plays a key role even more as the community targets a broader use of AI techniques, which can only become feasible if large open data sets are confidence measures for their quality are available. However, the current lack of common discipline specific guidelines for research data sharing opens the opportunity for misunderstandings about the true potential of research artifacts and subject to expectations regarding artifact quality. To address this issue, we introduce a set of guidelines for artifact sharing, specially tailored to MDE research. Introduction. The term reproducibility crisis has gained traction as researchers from various fields have reported challenges to reproduce studies. Software engineering research is by no means exempt from this phenomenon, as many authors in SC have faced difficulties when trying to reproduce studies performing replications with the direct support of authors and reusing artifacts in their own benchmarks. To mitigate these issues, SC conferences have started to incorporate artifact evaluation processes. In parallel to this, the Association for Computing Machinery has recently launched the ACM 6 Soft Empirical Standards document to communicate frequent expectation for research methods commonly used for their community. In model-driven engineering, openly providing research artifacts plays a key role for the following reasons. First, despite some attempts to provide a set of models in consolidated repositories and collections of UML models and transformations, there is still a lack of large datasets of models, diverse modeling language, and application domains. Having more systematic artifact sharing practices would help to increase the potential reuse of available models and support the evaluation of research tools and techniques. Second, the need for consolidated artifact sharing practices in MDE research has recently become more pronounced as the community targets a broader use of artifact intelligence AI techniques. Background: computer sciences becomes more important in all branches of the modern science after the artifacts are now seen as another important outcome of scientific research. They are necessary evidence to validate findings and results in most of the modern science. Help researchers building upon existing knowledge, encourage the adoption of novel research in practice, and increase the chances of citations. However, as numerous SC researchers report increasing challenges to reproduce studies, the reproducibility crisis known in the natural sciences or humanities is now an imminent threat to reproducibility, replicability, and repeatability of empirical experimentations in SC. Repeatability of empirical experimentations in SC research data management helps investigators to make a conscious about research data. It comprises various. activities from a data planning and synchronization over element standardization to data sharing and repository management, which encourage research reproducibility and software sustainability. Funding agencies and research councils have started to incorporate requirements for data management and sharing as a standard part of their policies. Artifacts in model-driven engineering. In model-driven engineering, rigorous abstraction models are used as a central artifacts in systems. Design and development process. Typical artifacts in MDE include models, meta-models, model transformations, and model tools. As such as the distant assets, MDE artifacts should compile with their requirements and quality criteria, such as model semantics and syntax and technology standards. Suggests that MDA artifacts should report information about aspects such as their context of use, usage restrictions, and business opportunities on top of the technical information, recognitional and social factors should also be considered as a source of issues that may affect the adoption of MDE tools and artifacts, such as sustainability over the long term. Approximateness for repurposing and resource to guide MD researchers and practitioners on creating and sharing high quality research data sets. Even more so as the MDE community aims to develop effective and efficient AI based MDE technique as the task can only become feasible if large open and good enough benchmark sets are available. Project quality management. In a survey of more than 1.5k PhD students from Europe and Israel, the majority of the uh, doctoral reported having no training or expertise in managing research projects. As doctoral research projects meets the same formal definition of project researchers suggest that PhD students should receive basic project management lessons to better manage their research as they move towards the successful completion of their doctorate. According to the Project Management Institute, project management is defined as the application of knowledge, skills, tools, and techniques to project activities to meet the project requirements. Project quality management is a PM knowledge area that applies all project regardless of nature their deliverables. It aims to incorporating the organization's quality policy regarding planning, managing and controlling a project and a product quality requirements so that the stakeholders expectations are met. So here is a picture figure designing a set of quality guidelines for MDA research artifact sharing, in which the first step we have the identification of best practices, and at the second classification of best practices like why, what, why, where, who, when, how much definition, and at the third phase definition of factual questions, and at the fourth phase design and refinement, and coming to the last phase survey with MD experts. And coming to the practices for artifact sharing, scripts to run experience, input data, raw data collected, scripts to analyze results, and identification of practices. Practices for artifact sharing, structured format includes scripts to automate the execution of experiments, includes sample input output data, includes raw data collected, includes script to automate the analysis of results. These are the examples of extracted and refined practices. So this is the conclusion we have. We now present our results, our practices, and the insights about the brought forward in our MDA expert survey. The presentation of results is organized into five parts. First, we give a brief overview of our practices. Second, we discuss our respondents, demographic characteristics, and experience with the research artifacts. Third, we analyze the challenges reported by our participants on artifact sharing and reuse, and how our guidelines address them. Fourth, we analyze how our participants prioritized our set of practices. Finally, we present our participants' assessment for the completeness, clarity, and relevance of our guidelines. Coming to the conclusion, artifact sharing is known to be helpful for researchers and the practitioners to build upon the existing knowledge, adopt novel contributions in practice, and increasing the chance of papers of receiving citations. In MDE research, there is an urge to and for artifact sharing as the community targets as the broader use of AI-based techniques, which can only become feasible if large open datasets confidence measures about their quality are available. In this paper, we introduce a set of quality guidelines specifically tailored for MDE research artifacts. This is about the